Check, check. All right, there we go. What a morning. Oh my gosh. Guys, I have some stuff to do today. I guess probably the first thing I should do, get this poor guy out of the way. Set him off the side. Check, check. I hope this is coming through. Hey, Matthew, what's up, man? Can you hear me all right? Is this coming across? I have to ask because, hold on. I can adjust the volume right here. And let's see, hold on. Check, check. All right, guys. Sorry, I've got to play around with some of my volume levels. There we go. All right. So I'm going to take off these monitors because I can hear the music that's playing and stuff with these ones. Once I take them off, I can't hear nothing. So that's why when I start a stream, I have to start out with these guys, and then I can eventually take them off. So guys, I have run into probably one of the most unusual problems, and I think I have a solution for it. But did you know that these computers are extremely fussy for how many USB webcams you have hooked up? Oh my gosh, it's so frustrating. So I have this camera right up here. I have this camera right here. And then I have my room camera, which is just not cooperating correctly. That's this guy over here, which it does work when I use other software. It's just OBS for some whatever reason. It's like, nah, we ain't gonna let you do that. So I have been fighting this for a while. It's so annoying. Here, there we go. I set it. And I should have a room camera, but I don't. So I've been fighting this for days. Like I wanted to go and put this stuff back together. I wanted to do a soldering video and stuff. I have been fighting the quantity of USB ports that I have occupied, and more so the amount of USB endpoints. Oh, this is so frustrating because the new motherboard, I have a mini ITX, and it's only got so many USB ports, but there's expansion ports and stuff, right? Well, here's my problem is I have my microscope camera, I've got that camera, that camera, that camera, and it's too much. That's why like my USB stops working and some weird stuff has been happening. It's just crazy. So I tried moving stuff around, maybe moving that camera over there to the front ports, moving some of those over there to a USB hub, etc. This is an AM4 platform, so it should have like 250 or so endpoints, and a USB hub could take like 20, 30 endpoints out of that number. A nice camera will take probably 8 to 10 endpoints, and it's so frustrating because I should have plenty of resources. I don't know if it's because I have a mini ITX board, to which I love that computer. I almost went and bought a different case and a different motherboard and stuff because of my aggravation. So I think I came up with a solution now. So the problem is you have only so many USB controllers, probably one, maybe two, on a mini ITX board. So I found this really neat device. Let's see. Give me just a second. Let me see if I can share screens and stuff. Amazon, of course I shut my keyboard off. I'm trying to be responsible. There we go. All right, and let's go into my orders. Guys, I do love me some Amazon. But it's because you can find solutions quickly, and that's really what I need. That's what this is all about. I need to find solutions really quickly, and Amazon does that because they have probably the greatest quantity of electrical adapters and stuff out of anywhere. I mean, it's true. And some of them come straight in from China. Some of them are you know, maybe questionable, but you know, in general, they have some crazy adapters. And I found one that goes from M.2, which is normally your NVMe drive, you know, your solid state drive that plugs in your motherboard, goes from M.2 to USB 3.2. And that is kind of cool. And it's kind of cool because, hold on, let me pull it up. What? Come on. Amazon, don't do this to me. All right. Manage profiles. All right. Guys, today is one of those days when I'm about ready to flip out. So my Amazon is trying to load some account that I haven't used in years. There we go. Maybe an account I didn't even know existed. There we go. All right. Everything, just nothing's working out this morning. Okay, so here, let me, that I have the item in question. Let's do a, room camera, split room, split desk. Right? All right. Anyway, you guys can see right here, it takes an NVMe slot or an M.2 slot, and it does have its own controller. So, gosh darn it, Amazon, stop. So you can see right here, it's got a controller. It's got a Gen 2 USB 3.2, and it's got a normal front end USB 3.0 connector. This one right here in the middle is the one that I'm really concerned with. And so basically this creates another USB controller for the computer, which should give me the ability to control all these cameras. And I know I'm lamenting here, guys, but I have been so frustrated with trying to get all these USB cameras to talk. And it all started with that troublemaker right there. As soon as I plugged in my screen capture device for the microscope camera, as soon as I plugged that in, it started creating problems. And I want to keep it plugged in because it works well when it works. Here, let's, oh, cool, see, watch this, What's up now? Here, let's turn that light all the way up. And if I needed to, demonstrate something, although my lighting right here is not too good. So if I wanted to show you guys some commutator bars, like right here, I could show you on my microscope, up nice and close, or further away. So if I'm soldering something, I can show you guys what I'm doing right here, which is really cool. The microscope is particularly dim, and I don't know if there's anything I can do about that. Maybe, does that add it? Hold on. I'm working on seeing if I can come up with a solution while we're live on the air. All right, let's check the same part. Yeah, I don't think that really helped anything. So anyway, the concept, guys, is to have my microscope and my cameras, make it switchable so that on the fly, I can go from one thing right to the next. So, and I can swing this guy over quite far, and I can set it up pretty high. It's got a beautiful focal range. So right now I'm working at about a foot. Yeah, and that's really rare because usually soldering microscopes are way closer. So at about a foot high, I can show you guys exactly what I'm doing when I'm troubleshooting boards and stuff. Oh, sorry, I'm trying to, there it is. So there, I could show you guys in depth what's going on. But, so everything now is working except for my room camera. And I see, it's supposed to have my room camera on over it, and it's not. And that is, oh, that's so irritating. So I'm almost there, guys. Like, my studio is almost completely set up how I want to. And so I figure I'm done fighting it, at least for this weekend, because I have got a mess and I need to clean up this mess. So I figured, you know something, I might as well just turn on the camera while I'm assembling some stuff and, you know, just talk you guys through what's going on here. So this is the suction unit that I just did a video on a couple days ago. I did go through and I cleaned the parts. I have a little brush and I got my deep sink over here on the side. So I've got a brush that I hook up to my impact driver, and I just give it a hot supper. You know, I flood the sink and I put my parts in there and I just scrub it with this guy and I clean the hell out of some stuff. But anyway, these brushes, you can get a whole entire brush kit with various size brushes and stuff for like $18 on Amazon, and they come with buffing pads and all sorts of stuff. All sorts of stuff that you could use for cleaning things. And once you use a power tool to clean, there's no going back. I mean, it's so wonderful. So anyway, guys, everything is cleaned. It still smells. You guys know that bodily fluid smell when something has been stagnant for a while? Anybody that's worked around Neptunes or anything, you're very familiar with that smell. Kind of a acidic, metally type of smell. That's what's going on here. Even though I washed these parts, and but they're clean, supposedly. They're not sanitary. They're clean. There's a difference. And I figure let's just go ahead and let's reassemble them. So the original problem that I faced was this guy right here. I love how my gloves all show nice and shiny on this camera. So this sealed bearing down here, or supposedly a sealed bearing, it was froze up. And you can see that after I squirted a whole bunch of fluid in there, I did silicone, that it freed it up and it's actually spitting quite easily. So it was the problem. It was completely froze up, which, since it's directly attached to my rotor, the rotor was froze up. And you know, I anticipated that there was going to be some hot spots like here on the commutator bars, but it's looking good. You know, because when a motor's froze up like that, it's drawing the maximum amount of current, and it's looking good. We'll put it that way. So I did clean the shaft up a little bit because there's a little bit of shmoo on there. That way there, it does not have any more issues. See, it's a very extremely tight fit into the brass, but there we go. And in hindsight, it looks like maybe me pushing it back in it found some more goobers or something up inside that channel. That is that tight of a fit. So anyway, there's one single set screw on the underside. It's an eccentric weight, so it's offset from the crank arm. And the crank arm, well, this is the crank arm, I mean, to be honest. But so as the motor is in here, and as it rotates, that weight offsets the pumping of the diaphragm, which is that guy right there. So that's basically what's going on. It's offsetting it to minimize vibration and stuff. So enough talk. Let's go ahead and let's see if we can get this bad boy back together. I'm sure this is going to be real fun. It's going to be a challenge. So one of the biggest challenges I had was reloading the brushes. So you can see what I did is I took two bread ties. There's two indents where you can pull back the springs that are pushing out on the two brushes. So I have one pulled back here and one pulled back there with two bread ties, and that opens up the channel so that I can reload the brushes back to their native position. So brushes will be kind of curved because they're going to sit right on the commutator bars like that. And so they're going to be curved. And if you load them an opposite way, I mean, because they are square on this particular one, they're square. So you could rotate it 90 degrees, and now instead of writing on, you know, the largest point of the brush, now you're writing on just 2 points, and you're going to create 2 hot spots, maybe even do some burning on your commutator. One of the things I haven't really found where it belongs is this little collet. Or it's not even really a collet, it's just a spacer. No really idea where this guy goes. I thought maybe I'd figure it out, but so far no good. So it has to be someplace down here by the crank. Oh, actually, I bet it sits right there. I can see a circle right here on the side of the crank. Yep, none on that side, definitely on that side. So it sat right there, which also explains why it's a little rusty, because it was sitting right on that guy, like that. Okay, so I found that. Shouldn't be too hard. So one of the first things I got to do is, oh man, not looking forward to this at all, because it was such a pain to get it off. So this guy here has to go down in here, just like that. And then the motor, I might as well, let's take a look. I think on this motor, I should probably start out by putting the brushes back on it, because they were such a pain and not fun at all. So put that back on there like so. I'm gonna keep these bread ties on until this is fully seated in the motor housing. So this guy here goes in like so. And let's see, where's my front face cap? So this is my rear housing. And what do I do with the front cap? Oh, it's still attached, of course. All right, so here's where this bad boy goes. And there was no preload washer on the front of this guy, only on the rear housing. So this guy is going to sit just like that, right there. Yep, there's 2 notches to line it up. Now it's probably safe for me to go ahead and cut those 2 zip ties, or not zip ties, but bread ties. Yep, there's 1. There's 2. Pull those guys completely out. Oh, no, 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 no. Oh. Guys, that's not cool. That is so not cool. All right, okay. Well, this is going to turn into a tutorial on showing you guys how to load brushes. Okay, well at least now I'm much better at doing it. So in order to do this, I need a large flat blade screwdriver, and you can see that there's a little indent. Here, tell you what, let's go ahead and drop this guy back down. Make it so much easier. There we go. How about that? Okay, right here. Yes. Okay, so this guy right here, my brush has popped out. There's 2 preload springs, and what you have to do is you have to push those preload springs back in, like so, and then wrap them with a bread tie, like this one right here, and that will secure it while you push the brushes back into their spot. It is a burden. So there we go. Now there's almost always like a some sort of gimmick that allows you to load the springs for the brushes in almost every single motor. You just got to figure out where it's at. Sometimes you can push the springs back and there's a little latch or something that'll hold it. I mean, I've seen a variety of different ways of doing this, but for this guy, I'm going to just push them all the way back and then use the bread tie. And hopefully I don't mess this up again. Okay, and as I said earlier, there is You could accidentally push these brushes in 90 degrees out, which would be not good at all. So you have to check and see which side is going to be right there. There we go. So I have to turn the brush 90 degrees, carefully push it back in its spot. There we go. There's one. As you can see, my bread tie right here. Oop. My bread tie pushing the spring back, and my brush sitting in there nice and even. And now this guy, the second one right here, looks like it's even more of a pain. Here it is. There it is. Okay, so I got the curves on both my brushes loaded up correctly. Let's put the motor back where it should go. All right. And let's see. It would be easier if there's some way of securing this motor better. Hold on, let me think about this. I need like a sleeve or a roll of tape or something. Let me get that. Haha. Exactly what I was saying. All right. So I got a roll of tape here to help me out, because the shaft of the motor has to be allowed to dangle, you know, freely. There we go. Just like that. Okay. And then this guy is going to be inverted because this lower section is going to be down. And then I have to push it back in. There it is. Okay, so now I have to hold this there while I remove the bread ties and not mess this up again. Okay, there's one. Jeez. All right, there's two. So my brushes are out, they're good. So now you can see the cutout that's going to mate up. Oh, there's my preload washer. Get in there. Do you guys sense that this is not going to go so well? Because that's what I'm sensing. Tell you. Let me see if I can carefully stack my preload washer and my flat washer, and then just invert the cap. There we go. Right, there's that one. Come on. It's almost there. Come on. What is going on? So my brushes are all in. It's lined up. I just gotta, there it is. I have to press it into the hub correctly. Okay. I'll tell you what I'm gonna do. I'm gonna go ahead and thread these fasteners down and maybe use the fasteners to kind of pull it in. So it should be right about there. I'm almost thinking that the problem is the bearing, because I did kind of pull on that bearing to try and get it off. So if I did unseat that bearing at all, then that is going to be my problem. All right, come on. It looks like it's going down. Yep, there it is. Right. Okay, something is not working out. It's because I need to keep my brushes. I need to lift this whole thing up as a unit. There we go. Okay. So let's see, this guy here. Needs to sit right. Come on. Right there. Okay. Then these two have to go down the sides. There we are. Oh, this is going to be real fun. This is why we don't open motors, folks. It's never easy going back. Okay. And what I'm doing is I'm pulling these fasteners back out so I can line them up correctly. You guys know. Okay. So right about there is correct. Nope, 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 nope. Oh gosh, guys. You guys ever figure out why nobody likes repairing things live on the air? because things never go as they're supposed to. Never. Like this permanent magnet, it's actually really strong. There we go. Okay. And the brushes want to pop out. The rotor wants to do its own thing. Come on. Jeez, right there is the spot. Okay. Right. So there's one. Now the second one's not in the pocket. Come on. So you see I found the threads on the first one, and now I gotta kind of swivel the cap, find the threads on the second one. Right there. Nope. Nope. So, guys, I got to ask you something. How do you guys feel about companies approaching employees from other companies? This is something I'm curious about because, I mean, maybe you can offer somebody a better opportunity than where they're currently at. How do you guys feel about that? Reason being is because I'm currently in this situation where, you know, interns from another company have been asked, you know, hey, if you ever need any help or whatnot, just give us a holler. And, you know, even though they're an intern, the owner of this other company was not happy about it at all. And I'm just curious what you guys think about that. Because, I mean, the thing is, if you really like somebody as an employee, then you're going to hire them. You know, you're not just going to be an intern. Furthermore, you're going to offer competitive wages. And if, you know, people normally want to stick with what they know. And if you're a good company, just being honest, they're probably not going to want to go anywhere else anyway. But the fact that your intern might even be looking for someplace else is interesting. But I never really seen poaching as a bad thing because, first off, it's good for the technicians, which is you and me. It's good for us. But it's bad for the company, true. I'm just curious because for me, I myself have switched several jobs, my share, I think, and I never really seen it as a bad thing for poaching. I mean, I've had several companies, even while I've been working for Fobi, trying to get me to come over and work for their companies. And, you know, I'll listen to all offers. I'll always listen to offers because, you know, while maybe I'm not what you're really looking for, maybe I know somebody that is. And so I listen to offers all the time. And, you know, I'll never close the door. So when like jobs are wanting you to close doors before, then you're just stuck with whatever that job's willing to offer you, you know? That's like the ideal situation for them, isn't it? I mean, we know that there's not enough biomeds in the world. So if there's not enough biomeds out there, that means you're going to have to pay more. And if you have to pay more, that means you have to charge more. But I mean, the way I see it is with junior level biomeds, you're not really going to be making a lot of money off them, if at all. And that, for me, is because you have to spend money to train them and you have to invest into them. So a lot of companies out there, they'll get like interns or junior level biomeds because it's cheap labor. And this is a very big problem. And I don't see it that way. I see it as an opportunity, and it's also an expense. All right, guys, so let's see. Here is my DC power supply. Let's see, I think I did black to white. Here we go. And we'll do red to yellow. All right, and this here, this is a 15 volt DC motor, so as soon as I turn this guy on, it should be cranking. Whoa, look at that. And there she be. And it's spinning its little heart out. So this is a little bit of white lithium grease. All right. I use this to clean it up a little bit. It's definitely got some power too. I'm squeezing the heck out of the towel. I'm trying to get it to shut off. And let's see. So let's see. At 15 volts, I'm pulling 0.44 of an amp. And let's see if I slow it down. Woo. Trying to slow it down. I can go up to 2.5 amps by trying to slow it down. So, there we go, man. This guy is back to working normal. So, next step is to assemble the plunger. Now that the motor's back together, the brushes are working great. If I'm only pulling 0.42 of an amp at 15 volts, that's good. That's really good. So yeah, I'm gonna give it one more bath of this lithium. I'm gonna get it down here in these bushings. There we go. Okay. So this motor was damaged by some fluid ingress. Now it's back up and going. All right. If I was seeing the current jumping all around or sitting excessively high, then I'd be like, yeah, this motor is dead. But nope, looks like it's good. Looks like this bushing is good. I'm gonna go ahead and put a little bit more in there. You see some of that rusty color stuff coming out. That's a sign that it's contaminated, and I might spray it, you know, try it again, spray it, try it again. I need to get that rust out of there. Should be wearing my safety goggles. You can see a stream of rust coming out of there again. Let's clean it out. Yeah, that's looking good. Okay, motor's done. Next, now we got this pump housing. And this guy right here, I also should, because it's a bearing, I also want to get some this white lithium grease down inside there. Now this is an interesting product because it can do stuff like this. Like it goes into small tight spaces because it's a spray, but at the same time it will kind of dry out and become like a grease, like a layer, which is what I really want to happen. The silicone is more so to get in there and free it up, bust up some of that rust that might have been in there. This white lithium grease is more for the long haul. Yeah, that's spinning so well. I just would like to get a little bit more of the spray up inside it. You can tell my desktop is getting the spray all over it. Ay, ay, ay. All right. So when I put this guy back together, I'm definitely going to spray it and then seal it back up. And, you know, considering these are normally oiled, self-lubricated, but in this housing, it'll be all right. I'll spray it one more time and then seal it up. So let's see, this guy here is going to drop in like so. Should be like this. The cam is going to be to the outside. And so here's where the motor is going to mate up to it. And there are 4 fasteners on this motor. This is what was preventing me from pulling it apart the first time, is because these two here, they are together. So let's do that. So there they go. And yep, looking good. So I got my 4 fasteners right here that hold the motor to this composite housing. And let's see, hold on. Putting fasteners into composite is such a pain, so that's why I dig using power tools. I use the heck out of this poor little DeWalt right here. So I use this guy so much. I'm putting some of this lubricant in my DeWalt because I was just using it in the sink. And you know, water and power tools usually doesn't go together too well, but I do keep the collet and the springs and everything, and I keep them basically running wet. That way there, I can do stupid stuff like use it to clean things in the sink. So I'm going to drive this guy down, but not tight. Tell you what else I'm going to do. It's going to be way easier if I use an extension. There we go. Yes. Way easier to use an extension. I know. A little bit too much. I get it. A little overzealous on the extensions. Okay. So I'm just driving them down till they're close. Now one of these fasteners, if I remember correctly, had my ground wire attached to it. think it's this little guy over here in the corner. There we go. I guess that's the good thing to use in extensions, is it makes it much harder to over torque something and strip something out. So there we go. Okay, so this guy is in. Now I just need to get this bearing to seat. Oh, nice. Oh, for some weird reason, I think I should have done that before I shoved it all the way on there. Come on. There it is. There it is. All right. I just got to show it some love. Come on. There we go. So it has to be back here in the middle so that it's not pulling on that rubber diaphragm one direction or the other. Come on, man. There we go. Let's see. I have a larger flat blade here for this exact reason. Just remember, guys, flat blades are not pry tools, right? Until they are. Until they are, folks. There we go. Did I do it? Woo! That's close. Come on. So the problem with is that you have to keep it going in nice and even, because if it torques just a little bit in one direction or the other, then it's not going to be good. And I have a little stubby shaft back here. I wish it had a little bit of a longer one, because then I could just grab onto it and rotate it and slide this guy on. Come on, man. Not gonna happen. All right, let's see. There we go. There we go. That's almost exactly where I need it to be. Let's see. I got, what, another millimeter? Come on. Come on, get off of there. There we go. Let's check it. Okay, so to check its centering, just put this guy on there, and you can see that I am off by, see right there, a couple millimeters. So that means I got just a little bit more. Come on. There we go. There we go. Let's check it again. Ooh, I think that's going to work. Let's see. Yeah. That's going to work. Okay. Sweet. So now that we got that guy set up, now I've got a set screw, a tiny little set screw to put back in. So here's the set screw. And it threads into the brass. Oh, come on. Come on. Get back here. And yes, if I lose the set screw, that's not going to be fun. That's not going to be fun at all. Unknown. I'm a bachelor biomedical engineering student in India. It's 12:17 a.m. Oh, bless your heart. Oh, you guys. I wish I could make it more entertaining. Just here's the process, and if I mess something up, then you guys will see it live. And here's the thing is, things mess up, right? It always is going to happen. It's how do you deal with it when it happens? And I guess that's one of the reasons I like live streaming, is because I can teach theory all day long, but I can't teach you how to recover when something goes wrong. So this is the one thing, you know, the process of troubleshooting and whatnot. This is the one thing I cannot teach, and the best I can do is show you how I do it, and you know, everybody kind of takes their own. Oh, that was a little bit much, huh? So what I'm doing is, that was a little bit of lithium grease. And what I'm going to do is spray it on here so I can clean off this diaphragm. There it goes. Nice. So if there's any debris or anything, it'll clean it off. There we go. And I have a nice lubricated diaphragm, which is going to be really good. Okay, so let's see, this guy here goes back on here. And let's see, next one's going to be a taper head screw. Let's see, I got 1, 2, 3. It's going to be this guy right here. You know, I just want to say, guys, that I completely appreciate the support that the international community has been giving me. That it means so much to me that I have some sort of impact on, you know, people completely on the other side of the world. So I absolutely love you guys, man. I think I have some of the best followers out of the internet, because I get constructive criticism when things are not correct, and at the same time I get you know, a lot of avid people that ask questions and they interact, and that definitely means a lot. Let's see. Huh. It's interesting. It's universal. Goes any direction. Okay. So these guys here just thread down into the bottom. Okay. So we should be able to test this and see if we have a vacuum pump or an air compressor. Come on. There we go. All right. Let's check it. Everything looks solid. Okay, guys. Let's hook it back up. Let's make sure that there's no oddball rattling sounds or anything, and let's do some quality control. Let's see, red to yellow, black to white. Cool, here we go. And let's see, we're still set at 15 volts. Uh-oh. Hold on, I have my amps regulated. There we go. Woo! I don't know, guys, what do you think? Looks good to me. Definitely blowing out a lot of air. Way out to here. It's got some pretty good vacuum. Oh yeah. Woo! So that was running 4 amps when we put it under a load. So that's looking pretty good for me, man. Looking pretty good. So didn't make any unusual sounds. That was the bearings in here. You know what I should do responsibly is I should I'm just thinking to myself. What I should do is let this guy run for a little bit. I know it's not meant for continuous use, but you know, I feel better about it if I just let it run. Maybe I'll just put it back in the pump and let it run and try from there. So anyway, here's the base plate. And like I said in my teardown video, if you ever have these recessed screws, they're going to be taper head fasteners. So that's going to be super easy to figure out what type of fasteners go where. And taper head fastener looks just like this. So yeah, you can see that it's tapered. It's going to fit with the chamfer that's already in the metal. There we go. Nice. And number 3. So notice how I'm not hammering down. If you're using power tools, don't hammer down, guys. I've used this for years, and so I know exactly how much trigger to give it, because I just want that one tap that kind of sets it. All right, so we got this guy. It is completely assembled. We have, well, now I think I'm ready to bring in the housing and start assembling it. Oh. It's my parts towel. I had to throw it over there. Colombia. Nice. Okay. Man, I got people from all over the world. Man, I love you guys. All over the world. See, normally people would think that, you know, everybody that watches this channel is just going to be, you know, Americans, of course. That's needless to say. But, man, people write me all the time from all over the world. I dig it. Okay, so inside this housing here, there's going to be some splatter. But I am not touching that splatter. All right, that is not happening. Okay, so the pump just slides in the bottom, like so. Come on. The case is a little bowed. Come on. There we go. So there's 2 little tabs like here and here, and I have to make sure that those tabs are holding this plate down. So it's funny because the plate adds rigidity to the entire machine, but at the same time, it reinforces that bottom deck, because that bottom deck is not rigid whatsoever. And it does move left to right a little bit. Okay, let's see, what do we got? We got some of these fasteners. It's going to be those 2 right there. Here, might as well move these in so y'all can see what I'm dealing with. Oh, come on. Jeez, come on. I did that so well, and then I don't know what happened at the last minute. It just kind of boogered out. So I use this technique where I hold the fastener on with my finger just to get it down. And I've done that for years, and it works for me. I don't, everybody does things differently, but this has always just worked for me until it doesn't, like right now. And sometimes you get like those really nice magnetic screwdrivers. Come on. There we go. Magnetic screwdrivers, like so. I do have some. I just don't know where they're at. How about this one? Better. There we go. All right, there we go. That one's tight, that one's tight. We're good. So this lug back here was all my grounding straps. And let's see. So this grounding strap and this one, they all kind of went on there. So first was that one, and then there was a fastener, and then there was the other ones. Oh, come on. Let's see. That's why I have all my tools right here. You know, you guys would be surprised at how much stuff I fix on the daily. So I was thinking about creating a whole separate channel where I fix non-medical stuff, because it happens like all the time. And, you know, really it came down to time. Just running 2 channels full time, I can't do that. Plus I'm vice president of a medical company, and that takes a lot of my time. So just was not happening. Plus I'm traveling around the country, giving speeches and stuff at events. It just was not working, man. So maybe I'll just do live streams like this every once in a while where I can answer people's questions. And then at the same time, maybe repair some random stuff that comes in the door, because I do get some random stuff, guys. Okay, let's see. What do we got? I've got this port, which needs to turn, and it's not turning. Come on, there we go. So this port has to turn. Here's my cable for that. Okay, there's that one. Okay, so my vacuum is now hooked up correctly. This strip right here comes down here. And I have a fastener that's gonna have to go on that. My other grounding straps, they all go over here, like so. There we are. Come on. There we go. Just like that. I know, I'm using the wrong tool for the job, right? I know what you guys are thinking. You'd be surprised what some good stubby jaw needle nose can do. Okay, that plate gets that ground. These two are up here. One of these is going to go to the back, which is why it's got the fastener already in it. And let's see. Everything else looks like it's going to check out. Let me get the back of the case. Which I don't know where the back of the case is at the moment. Oh, it's over here. Gosh, guys, I'm so tired. All right, all right. this one. It's going to go over here. I can do that at the very last. Okay, so let's see. This one here is going to be for my main motor. Got my AC in. And let's see. All right, let's see. Where's that other ground? One of them's going to go up to my motor. I know that. So I might as well just pull the one that I said earlier. Let's move this over here. Let's pull him out. Let's put the proper hardware in there, which is one of these spurs. It's grounding wire. Oh. Come on. Stop. There we go. Put him back in. Okay. So my grounds are correctly installed. I've got this guy here, which is going to come to the back case, but we will do that probably at the very end. Oh yeah, that's where he went. He went right over here in the corner of my power supply. Okay, so let's see. This guy, I'm going to tuck him up underneath the motor mounts. I do need a fastener for this guy. And that's for the front strap ground. I don't even know why they need it, but whatever. Okay. Get my stubby jaws again. There we go. That's good. So here's my two halves. This guy here is going to plug there. This guy here is for my motor. This guy here is for my AC in, but I think first I should probably connect this guy. So this right here is my ground. I like how it has the screw captive because it's bent at such an angle. There we go. Okay, so there's my ground. Here's my AC in. Nice. Okay, and then this large Molex right here is my front panel connectors, or all my buttons and indicators. Okay, everything's plugged in. It's looking good. No pinched wires. Okay, and then what I'm going to do is I'm going to throw a couple of these fasteners in here to secure it while we test it. Okay, there's one. These are some really long fasteners too. There's two. Okay, and the third one goes back here in the corner. So, mind you, I'm using hand tools for this, and the reason being is because the brass pockets, which are nut pockets, are just pressed into the plastic. So, definitely a no-go for using power tools for that. All right. Okay, so here is my muffler housing. And this guy's going to go just like so. Doesn't really do anything, it just creates a little bit of a baffle. That's pretty much it. Let's see. I tell you what, I was thinking about it and I was like, you know, I might as well just put the fasteners in the handle here. Let's just put it all back together. If it works, it works. If it doesn't, it doesn't. We're okay. There we go. Handle, and I had another one over here on the side. Yep, this guy right here. So that holds my main device together. The basket is the other fasteners. What? Come on. Come on. That's not funny. Okay. Let's try this again. Let's put some of these screws back in. There's one. There's two. There we go. All right, our pump's back in. What do you think? What? So let's go ahead and screw this guy down to increase vacuum. So it does have vacuum. I don't have really high vacuum, but it does have vacuum. Just curious to know if you perform electrical safety analysis after a repair. Absolutely. Anytime you have to open a device, you have to do an electrical safety afterwards. For one, to check your grounds, because as you've seen, there's a lot of grounds there. Of course, that's an issue, but only when everything is absolutely working perfectly will I do that, because the chance that you have to go back in and open the device back up are pretty good. Like right now, I'm not really getting the vacuum numbers that I'd like. And is that because the unit is defective? I don't know. It could be because it's running off battery. Maybe that battery's low. That's probable. So what I'm going to do is plug it in. Let's see, what do I do with my AC cord? All right, well, I have to get another one. Okay, and on this guy, oddly enough, the power's in the front. The indicator lights came on, showing it knows it's plugged in. That's good, yay. Notice the difference. So it's possible that one of those seals on the pump is maybe a little contaminated. Possible. Possible. Well, guys, it is pumping its little heart out, but I'm not getting the values that I'd really like to see. So I'm going to leave it charging while I just open it back up real quick and make sure that those hoses are on pretty good, because it could be a hose leak. Could be. That motor seems to be running pretty strong, and it was definitely pulling my gloves way tighter when it was just the motor sitting here on my desk. And it wasn't even running at that high of RPM when we did our test earlier. So that is telling me automatically that this guy is maybe a hose leak or maybe a crack. Maybe, because if they do fall on this front face, if they smack that knob, it's all plastic right there. And you can and will crack your housing and then cause other leaks. So, all right. So, this is why I don't do electrical troubleshooting right away. Electrical safety, because there's a good chance you'll have to open it back up. I should have just did a leak check with the clamshell still open. That probably would have been smarter. But I was being a little too assertive. I thought, yeah, no, I did everything right. Little did I know. Okay. Here's the clamshell. Let's see. This tube is on there right. This is on there right. Tell you what. I can pull this guy back off. Yeah, that definitely felt like it was loose. Let's go ahead and turn this guy back on. That's a pretty big difference. Pretty big difference. Okay. Well, so this right here is silicone tubing, and it is kind of a loose fit on there, man. Here, let's power it on. Let's see if that's where my leak is. Nowhere near as strong up here. Do I have a leak down here? Do I have a leak? How about here? Let's check at the other end of this hose. Oh yeah, that's good. Look at that. Okay, so the hose is all right. Seems to be my problem is at the gauge, right after the gauge. Shoot. So one of the things I usually do on silicone hoses, because they're so loose and just floppy, is use zip ties and put a zip tie around the barbed area. And I would normally say that would work, but in this case, I don't think that's all my problem. Let's see. Okay, you guys can see. So the next thing I want to do is pull the hose off this side over here. Come on, there we go. And this guy. Come on. It is not playing nice, guys. All right, let's see if I can pull down and out. It's such a short piece of silicone tubing. There we go. Okay, let's try it again from here. Nope. Okay, I have a defective part. Right. So someplace up here. Oh yeah, there it is. There it is. All right, let me show you what I'm looking at. Okay, so watch right here at the gauge housing. See that? Look at that. And there she be. So in order to pull that part, I'll tell you what, let's disconnect power. And there's a set screw on this knob. And it's probably a standard size knob too. Let's try 5/64. Wow, I am just getting lucky lately, guys. Here we go. There it is. There it is. Come on. There we go. There we go. Keep that spring. I'm going to pull this nut off right here. And once I get that nut off, then I can pull the entire gauge cluster out the back. All right. I should keep pliers like this up here instead of over there in my toolbox. All right. So this is going to be probably one of the more common failures that you're ever going to see with these machines, is going to be the gauge cluster failing. Oh yeah, yeah, for sure. Yep. So take a look right here. You can see part of my threaded fitting for the gauge. It's cracked. See it? So, as a medical device, this guy probably isn't worth fixing. Probably wasn't in the first place. But I can tell you that that's an absolute shame. What I could do, well, I can probably order this part. It just wouldn't be from the OEM. It's, what is that, 3/8 or quarter inch? No, it's 3/8. Yeah. There we go. Yeah. So it's 3/8 pipe fitting, and that would be a vacuum regulator body, which would come with the gauge. Oh, but you know what's the stinker of it all? You guys. Right under here, and right here are the fasteners. So you have to replace the sticker on the front in order to pull the gauge cluster out. God darn it. So here on the back, you can see that strap that's holding it down? See that? The metal strap right there. It's threaded from the front, which means that I'm not going to get that sticker. Probably not. That's ridiculous. Anyway, what can I do for this guy? I probably could have found this part right here as a vacuum regulator block, but that strap holding this guy down from the front, being front threaded, that really sucks. There's not too much I can do about that. So I guess this pump is gonna have to go in the parts bin. Oh well, it was entertaining, guys. It is what it is. Sometimes you really gotta just count your losses. There's some really good parts on here. I mean, from the IEC to the power supply to, I mean, almost everything. Technically the motor is okay, it's running fine. Stupid gauge set. Oh well, I don't know. I'll look it up. I'll see if I can find another one. It is what it is, guys. And the whole purpose of this video is so that I can clean up this desktop. Here it is. I'm just making another mess. All right. Well, okay. Well, you guys should know that one of the first things you should do is put away your Allen wrenches like first, because they booger off and a whole entire Allen set's wasted if one of these wrenches is missing. So, you know, make sure you take care of those first. I keep one of these type of screwdriver sets, and every one of my drivers does have a special home. Let's see, flat blade, just like so. Some of my other stuff, gosh darn it, look at this. I really wanted to fix that today and get that just off my list. Catherine, how are you doing, ma'am? It's a beautiful Sunday morning, and I'm just sitting here and just trying to clean up a little bit. It is what it is. Never close a PC case before it's booted for the first time. Yeah. So Catherine, I've seen a lot of your comments and you seem to know quite a bit about computers. I am having a situation here with this PC. I fought it most of the day yesterday. I've got three, let's see, 1, 2, 3, 4. I've got 4 cameras connected to this PC and it does not like it at all. And so anyway, what I end up trying to do is because it's a mini ITX board, I was thinking, all right, there's a good chance that there's only one USB controller on there. I'm lucky if I got 2. But so I have a M.2 adapter, which converts my PCI Express, which is, you know, where your NVMe would normally connect. It converts it over to USB 3.0. So I showed in the beginning of this that that's my solution. It's going to give me one more USB controller, maybe for my 4K camera or something. As soon as I connected my microscope, which is this guy right here, let's see, microscope, let's bring it on over. So as soon as I connected my microscope to the machine, that's when all hell broke loose, and that's when I started having lots of problems. So overhead, I switch over to this view, move my camera back, but my room camera just will not work. Look at that, won't do it. So I'm using OBS Studio, and just OBS, it's got its own issues. But yeah, so this one right here is supposed to be like a split room, so it shows like what's going on in the room, plus like right here, doesn't work. So yeah, and I got my normal green screen back here. Oh, look at that. It doesn't like these gloves. Apparently I'm disappearing. And then my split desk, which is this one right here. This is going to be one of my favorite views because I can get a lot of stuff on camera at once. I can talk to the camera, meanwhile do my thing. I think this is going to be my favorite. So put my stuff back. Oh, what a day, guys. What a day. Put all my parts back. So I've got magnetic strips right up here, right in front of my face. And these are super nice. If you guys don't use magnetic strips in your workshop, you are definitely missing out, because these guys, having all my tools like right here where I need them, it's invaluable. And I got my flush cutters, my needle nose. I have everything like right here on my back wall, except for these. These have a special drawer that they sit in, and that's because these ones here, Allens, tend to rust quite easily. It's just the nature of the metal, and even though this is climate controlled, they still want to rust, so I keep them kind of wet and sitting in their own drawer. So let's see. I did have some other stuff that I wanted to show you guys because, man, I got some cool stuff that I'm working on. But yesterday, almost all day, I fought my USB. It sucks, but I think I kind of got it figured out. My 4K, my Osbot, which is quickly becoming not my favorite camera. Definitely the most expensive camera, but it's a POS. So now that I have a space, I can show you guys what I wanted to do today for real. So I have some of these HTM Workshop. I did a whole video on these. So I have an ECG simulator and I have an ECG reader. And this here was going to be one of the reasons why I need the microscope, because I want to assemble these live on the air and run through them. They're a neat little parts kit. They're based on the, hold on. I believe they're based on Arduino. Well, they're based on the Nano right here. So yeah, it's a very cool kit. He actually included batteries and everything. So neat. So let's see, which one should I do first? One of them is going to be the reader, and one of them is going to be the simulator. and then you program them and everything. It's such a cool kit, and I've wanted to build this for a while, and I just wanted to have the correct facilities to do so. So that's one of the reasons I've been busting my rear end, is to make this happen for this exact experiment. So guys, let's see what I have. This is clearly my reader. It's my reader because it comes with the ECG leads. It also is based on the Nano. And this one over here is going to be my simulator, apparently. Cool kit. Which one should I do first? Let's see. Let's see. I could recreate the sticker. Not worth it. I do have some spare parts because I work on some cool stuff, so I will keep these parts for sure. All my cameras are using USB except for the microscope. My microscope is using a video capture. So I understand that 4K video capture piece is probably using quite a few of my USB endpoints. But it is going to a USB-C hub, and that from there it goes to my USB-C port. And it is just not having a good day. I wonder, hold on. No, I plugged it. So my Osbot, I plugged it into my front case, because normally your front of your case is going to be probably a different USB controller than the very back panel. I don't know. But my solution is going to be that, that M.2 adapter, which is going to be super cool. I hope it works. I do. Just more stuff inside that case, because I do have an M.2 port that I'm not using. So let's see, I have in this kit, oh, I guess I should be a little more careful. Right here's my Nano. Right here is my PCB. I'll tell you what, let's go ahead and swing this bad boy down so that y'all can see it maybe a little bit better. Come on. And let's switch. Bam. Okay. So right here is my Nano. Come on. There we are. Pretty cool. It's the basis for a lot of kits. It's basically a computer on a chip, and it will go here on my PCB. This is a very nice PCB. Look at those nice through holes. This could be fantastic. Very thick quality. Good screen printing on it too. So let's see. I got that. I've got this. That's the only thing with this microscope, is I should adjust the focus for a really long focal distance, like that. There we go. Just set everything out, let you guys see it. So I have a series of resistors. He does have 10K ohm written on there. Thank you for that. Other words, I'd have to look it up with Google Lens, guys. Google Lens is the way to do it. Let's do split desk again. There we go. So I got a couple risers. Now these are cool because they keep the heat away from the system on a chip. I could solder this guy directly, but then you're kind of stuck with it always being in circuit. And this way here, it's more repairable, but at the same time, you're only soldering in these little risers. So this is just a press fit at that moment, which makes it so much easier to maintain if I have a problem in the future. Plus it keeps the heat away from that guy. Extends the life. Let's see, I have a couple 100K ohm. I have an LED, yes. AA batteries, taped together, I love it. And some tiny little switches. Yeah. So these are dual pole single throw switches, just tiny, very, very, very small. I've got a screw down terminal, a couple gator leads with terminated ends. That's cool. There's another one, so there's 3. What is this guy? 1K ohm resistor. 220. So Google Lens, I don't know if you guys have ever used that app before. You can take a set of resistors like these and just take a photo of them with your camera, and they will tell you exactly what their values are. It's so neat. Speeds up the process considerably and user error, because sometimes, you know, we see one color and maybe it's not completely accurate. Let's see, I've got a couple of tiny capacitors. And let's see, what is this? A 22 kilo ohm and 530 ohm, I think that's what it says. And that's it for the simulator. I guess let's go ahead and set that guy off to the side. And it comes with an instruction book. You can find additional resources. I love QR codes, guys. I love QR codes. And you know something? What is going on there? Guys, why do I have a white bar behind my head? What is going on with my cameras? Hold on, y'all. Hold on. Let's do that. Over table, split desk. Let's go down to green screen 2. It is just pulling up a bunch of stuff. Oh, it's all stupid. So stupid. It's my microscope. All right. Let's just put him off over the corner. And let's see, what else do I got that's interfering? It would be over here. That's distracting. I can't help it, guys. Sorry. I don't now. That's for darn sure. Did you install the chipset driver for the AMD B550? I did. And that was one of the first things that I considered, because it's just one of those things that you would expect to maybe go wrong. Hold on, let me switch back to my split room. There we go. We're back in business. No more annoying things in my video, except for this black thing right over here. My camera's in frame. There we go. Sorry, too many moving parts in this shop. Okay, cool. So let's walk through the instructions and see what he has to say. Verify parts. We got Arduino Nano with USB cable. We've got all that. Screw terminal for 3. Yep. 2 female headers. That would be these 2 guys up here. Let's see, what else do I have? PCB, yes. Portable USB power supply, yes. 3 single pole dual throw switches. Wait a minute. I would argue with these switches. He calls it single pole dual throw. This is single throw dual pole, because you're switching either this one or this one to common, which is your middle. So single throw means it moves in one direction. Dual pole means that there are 2 different switchable contacts. So I would have that discrepancy, sir. Okay, and I could be wrong on that, but I'm pretty sure that's accurate. Resistor 1K ohm, 10K ohms, 330, yes. 100, yes. 220, yes. And R12 is 22 kilo ohms. And I have 2 220 nanofarad capacitors. Yes, we have everything. It says solder your components on the PC board. The location of the components are labeled on the PC. They are. I didn't even notice that. So yes, all the values are there, which means I technically don't need any instructions. Okay, so let's see, so here's my capacitors, yes. So when I install components, what I do is I put them in, I split the legs like that, and that holds them in. Let's put this one here, put that one there. And I'll get a few components in, and then I'll move the microscope over and I'll solder them up. 1, 2, 3. All right. Well, I can tell already this is going to get busy. Let's go ahead and clear off this section so I can just start soldering. I can solder pretty quickly. So, and guys, that's because I've got years of experience doing it. So, if anybody gets aggravated or whatnot, it's a technique, and part of it is also the tools. Just make sure you have the right tools. I've seen so many people try to solder with garbage soldering irons, and that is not going to work out well for you. Not very easily, anyway. So let's see, I've got my DC power supply over here. Hold on, guys. I'm coming back. So I've got my terminals all sitting up there, whatnot. Soldering irons on. And this is going to be interesting because I will probably have to solder standing up, which is not the best scenario. Let's see. How about we do some of this right here. Let's do overhead. There we go. Okay. I wish that guy was a little bit closer. You have a TS100. You know, a lot of people ask me to try out the TS100, and I have not. So I have some unique things, like this guy right here, which is just a lighted fan. I think the fan is probably not as useful as the light. There we go. So the goal is to light up your workpiece, but also keep the solder out of your face, you know, the resin. Okay, there we go. And swing this guy back around. Hopefully this works out. Okay. What could possibly go wrong, guys? Let's switch it over. I can already see that I need longer cables for my microscope. Oh, are you kidding me? Yep, my cables on my microscope are not long enough. Oh, yeah. Okay, right. Will it work? It's working. We're good. So let's go ahead and set up my job. Okay. So I'm going to be soldering from right there. Let's see. It's a little sensitive on that focus. There we go. Okay. There we go. All right. So what I would like to do first is to get my headers and the block, you know, get a lot of the larger hardware, get that all soldered in first. You can see what I've got going on there. I've got my terminals facing the outside direction. Soldering iron should be heated up. So I'm going to flip this guy over. Oop, there we go. Flip it over so that port is sitting nice and flat. And let's do this. All right. Okay. So you guys just want to be sure that when you solder some of these ports, you are heating up the socket, not the pin. So get a little bit of solder on your iron, get it down in there, press your iron down on the port, bam. So now that one is in there good. Check it, make sure it's sitting flush. It is. So I'm using a, what is that, 1.5 millimeter semi-conical. Let's see. Yeah, I don't know if I can get it so you guys can see it. Yeah, so it's a shaved off cone, and it's more like a wedge. And that allows me to put a lot of heat right where I need it. There you go. So I'll inspect it. There we go. Looking really good. Okay. So now I got these capacitors. Let's go ahead and just sink those guys down real quick. Okay. And if you're ever doing this kind of work, you should always have your flush cutters sitting here, which mine are, over here. Okay, so flush cutters, they're these style shears right here. Super handy. And I just realized I don't have a stand for my soldering iron. There we go. Okay, so flush cutters are for getting right in here, clipping these guys out. Just be careful. I should be wearing safety glasses right now. Okay. So when you're done, you should have neat little cones, like I do right here on each of those, and on each of these. Too easy. All right. Next, I'm going to put my risers in here. These are the female risers. There's one. There's two. Okay, so these ones here, you want to make sure that they're as straight up and down as possible before you solder it. So solder one pin, check it, because if they are crooked, then your chip will not fit naturally. Okay, so right now, I think I have them all setting exactly where I want them. I'm going to get these two corner pins. One. There's two. And, right, so that holds them in. I want you guys to take a look that even when I'm being careful, you see how they're not completely straight up and down. So I've only got two pins being held. That allows me to move them around a little bit. There we go. Uh-oh. This one here popped out a little bit. Let me straighten it up. There it is. Okay. So now you can see right there. Pretty much straight. This outside one, all I gotta do is push it in a little bit and solder another pin. It'll be all right. Okay. Notice how I'm putting some weight on it, even though it's just my pliers. That keeps it down. There we go. There we go. There's two pins. There's two pins. All right. Are they lined up? Look at that. Beauty. Okay, so I've got 4 pins, the 4 corners, and now I will just go right down the line. Start getting them. No, there it is. You know, it makes it way harder trying to keep this in frame for the camera. It makes it way more difficult. Let's see. Okay. All right, so next is the most important thing. I got one of those risers already done. So now let's go ahead and let's check it, like in some detail. Okay, so you got to put it up at a little bit of an angle. I know there's not really good lighting here. I wish I could fix that. Hold on. Maybe I can. Oh no, 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 no. Okay, one of my next projects is going to be a screwed down holder for my my soldering iron, because it wants to tip so easily. Why do they make them so skinny? Soldering gun holders should not be skinny. If anything, they should be fat. Anyway, I'm gonna screw that bad boy down. Okay, there we go. Okay, let's see what we're doing. So you can see the side profile of some of these. Let's see, really close. And you can see what's happening on some of them is the solder is actually going through to the underside of the socket. So technically up close I can see they look like they're soldered kind of well, at least from the front side. You can see on the back side some of those pins could use a little more solder. So that's what I'm going to do. That's why it's super nice to have a soldering microscope. There we go. Okay. I'm going to try and keep it right there, right in frame. Jeez. I should just draw a square so I know a reference where to keep it. Okay, and my soldering tip is now bent because it just took a dive off my table. It sounds like kids are dying outside my building right now. It's because I think the neighbors are over and they decided to have a screaming fest right outside my window here. Okay. Okay, I got 2 bridge pins right there. That's how you can break the bridge. It's just put the iron down there. Solder is attracted to the heat. So you can see I got a lot of flux on there. That's from this flux core solder that I'm using. Makes it kind of difficult to see what's really going on down in the socket. Okay. Alright, so that riser looks like it's pretty good. Alright, let's see from the back side again. It's easier if I got a fancy backdrop. You can see how well those all look. There's one pin like right here that might be questionable. Let's get that one pin. Let's see, that would be this guy right here.
Let's get this guy right here. I'll tell you what, with all the cameras and the lights and stuff, it actually makes it a little difficult to see some through the flux because the flux is so shiny. All right, let's clip another piece of solder. Let's check it to make sure it's still linear, the two. Okay, there we go. Now let's get the second rail taken care of. There we go, let's do it. I'm at the right angle for the second rail. I can actually see it a lot better than the first one. It's going a lot faster because I can see it. Beautiful. All right, let's go ahead and show you guys what that second side looks like. There you go. See, I got a little bit of solder from the pull away right here on top of this guy. And let's see, I got a little bit of splotch between the pins. I'll clean up. Okay, and let's see, I got one piece right there. There it goes. Okay, so we're clear. Hey, sweetie, what you doing?
I wanted to see.
You wanted to see? You're making a lot of noise outside. Okay.
There's a visitor in here.
Okay, go play. Right? Chop chop.
What?
Okay, so here we are. Next, when we're all done with this guy, is we're gonna take some 99% alcohol, and we will go over it with the alcohol and clean up all the flux that's left over on the board. Okay, go out. Thank you. All right, so let's see, we got that, we got that. I've got some of these switches. Let's pull this guy up so that you can see how I assemble it. So it says I've got switches, so switch 3, there it is. Switch 2, switch 1. Okay, so all the switches come over here. All right. What would be the best way to tack those guys down? The best way would be to put some tape or something over them. I'll tell you what. I'm going to do something a little special. Oh, no, I'll tell you what. Here's what I'll do. I'm going to bend the legs to the switches in opposite directions because I'm going to clip them anyway. There we go. Okay. So the legs to the switch are bent. You can see up in the corner there. That holds them really close to where I wanted them. I really just don't want them flopping all around. So what I can do is I can hold them in a spot and then just throw some solder on it and tack it down. And that's what I'm going to do right now. Okay. All right, there's my first switch. And it is not very flat. So let me see if I can heat it back up. There it is. There it is. So it was mounted a little crooked. I'll give him that. It was my fault. So I just used the solder that was on my tip, and I tacked down the middle switch. So that always works as well. Just tack this guy down at the other leg, and then the middle leg. Perfect. So now I got two switches that are sitting on there nice and pretty. I got this third one that's flopping around. Just line them up. Okay. All right. So now I got all my legs down. Now I'll clip them with the flush cutters. Because bending the legs like that is not going to be good. They're sitting really close to some other ports. Okay. All right, so let's check the profile of those three switches. Yeah, they're a little loosey-goosey on there, you know, not perfectly lined up parallel, but that's all right. I didn't apply very much heat to them. You know, I just tacked them down real quick. Since there are a lot of plastic components in there, that could really affect things. So let's see what they look like. So under the microscope, they look good. Okay. What's next? So I got my three switches. I've got my LED. That one's simple. I'll tell you what. I should know this, but since I don't know it, let's go ahead and look up what's the cathode for an LED. Okay. All right. So whenever I haven't done anything in a while, I will look stuff up all the time. And one of the things that you should notice is that one leg of the LED is longer than the other. Okay. And that is because, let's see if I can pull up another image of it. Come on. Come on. Well, it's not really pulling up too well. The longer leg is going to be your anode, which is the positive, and then there's going to be one side that's your cathode. So the flat on your PCB, so right here you can see the flat, is your cathode. So your cathode is going to be the shorter leg. So the shorter leg, boop, just like that. And mind you, it only works one way. So there we go. You can see I split the legs to hold it in place and hold it flush to the board. So that's what we're going to do next. Because it's a kind of a larger oblong component. All right. And these will definitely get cut off. There we are. Much better. And if your solder is jagged when you flush cut it, all you gotta do is touch it with the soldering iron real quick. Boop, boop, just like that. It rounds it over, makes it look nice and beautiful again, and you're back on the road. You're ready to go. Okay, so there's my LED mounted to the PCB. Let's see, what is next? I have 10K ohm resistors. I've got a bunch of them. So let's go ahead and let's do those next. So they did such a nice job. They labeled them 10K ohm. So we're going to take all these guys right here and just thread them in all my 10K ohm spots. All right, let's do this. So I'm going to fold them over. That way there I can just push them in all the way down to the PCB. Spread the legs, just like so. Yeah. It holds them nice and flush. And I've got a series of them, so let's go ahead and do them all. There we go. And you can see that they're not sitting completely flush. So what I do is I grab on the leg that's not flush and I kind of roll it, my finger to the side, that pulls it tight. And that gives it that nice flush look. So you got 3 more. So resistors are omnidirectional. Doesn't really matter what side goes where. Some people like to line up the stripes and stuff. If you do, more power to you, man. More power to you. Okay, so there we go. And I got 2 more 10Ks. So I just hold the resistor body, fold the 2 legs down. And let's see, 100K, 100K, and these 2 are 10Ks. Okay. Here we are. Good. All right, so this is the last 10K. Ouch. Let's see. There's that one. You see how this resistor is a little lifted? Oh, right there. See how it's lifted? So that's what I'm talking about. I'll just grab onto it, kind of roll my hand, and it pulls it down. There we are. So now we got all our resistors in place, all the 10Ks. We'll just solder them up nice and quick. So notice my soldering iron goes down on the socket and I'm warming up the socket because that's the most important thing. Oh, almost got too many resistors on here to solder comfortably. Okay, and let's see, I've got one more that's in question. This one right here. Beautiful. All right, so now we flush cut those. So you can see on this one right here, I'll show you a little bit of a close-up. You can see that the solder is more like a ball. And when solder is more like a ball like that, that means that you didn't get enough heat down there and you need to touch it up. So I'll show that up close so that you guys can see what a bad socket looks like and what it looks like after you touched it up. Okay. Let's see, where's that bad socket? I think it's this guy right here. Okay. Where's in frame? There it is. Okay, so this one right here. Oh, oh. So this little guy right here is kind of round. So what I do is I touch it with the soldering iron, and what it does is it seeps into the socket, and by seeping in it creates a better bond. I might as well just do it for all of them. Just touch them up. Yep, that's that guy right there. Good. Beautiful. So that's what I'm doing, is just touching them. That looks pretty darn good if I say so myself. Okay, so all my resistors are in line. So now I'm missing just a few more components and this guy's done. Look at all these clippings. I should have a little broom or something here. Keep that nice and clean, because you'll get these in your arm. These little stints of metal. All right, let's clip another piece of solder. I have two 100K ohm resistors. So let's see, where are my hundreds? I've got, right here's one. Okay. And here's the second one, right up here. It's interesting, the little matrix that they create. All right, guys. So there's the 200Ks. Let's go ahead and get those fastened down. Quick and easy, man. Having a good soldering iron makes it so much easier. All right. I can see one pin right here that needs some extra heat. I got it right there. I'm really picky about my sockets. So if I see one of them that's not uniform, I will go through and just retouch it. I'm not liking that one. There we go. Nice. There we go. Perfect. Okay, so I just went through and checked all my pins yet again. My 200Ks are down. I've only got a couple of components left. What are these? 220s? So I got two 220s. Use a smaller. You know, I should have an acid brush. You are absolutely right. The wire does have flux inside it. Yes. So this is rosin core flux. Given this one's a little old, but yeah, based on the diameter, that's how much flux you're going to get. All right. Let's see. I really need to draw like a square down here so I know where the camera frame is, because every time I move the board to take a look at it, I take it out of frame. And I'm sorry for that, guys. That's, I guess we can chalk that up to inexperience or just the fact that I need to see what I'm doing. Handy Mike, what's going on, man? So this is today I was cleaning up, but really what I'm doing is I'm finishing up some stuff that I meant to do for a while, and one of them is assemble these HTM Workshop kits, and this one here is going to be the ECG simulator. So it's a patient simulator that I'm assembling. It's almost done. So I've got just a couple more components left to throw down. These are the 220 ohm resistors. Here we go. There's one. There's two. And let's see, this second one over here is being a little bugger. There we go. Okay, so the key is to get them as flush to the board and as nice looking as possible. Yeah, I've been holding off on these to do these kits for a month. And man, if you guys knew me, like soldering kits are, I love them. So it's been torture for me to not assemble these and see what they're like when they're done. Okay, those look good. Let's cut them. Go. Nice. Cool. All right, what else do we have? We have 3 more components to solder on this board. 3 more. So I have a 1K ohm here. And let's see, where's the 1K? Oh, it's over here. This 1K is probably for the LED right there as a driver. Maybe I'm wrong. You know, LEDs, they will go until failure, so you have to have a resistor to limit the amount of current that is allowed to go through it, because LEDs naturally want to run too short, which means you know, they want to increase the amount of current through them more and more and more until eventually they just pop. And that's pretty much all LEDs, which is why we have to have LED drivers. Oh, that was a hefty little resistor that I just put in there. That was one of the worst ones for bending the legs, because the diameter of the legs is so thick. It means I gotta make sure it's got plenty of solder on there. There we go. So that's my 1K. Next, tell you what, let me bring this guy over so I can do something like this, or like this, or like this. There we go. There we go. All right. So eventually, I also want to set up one screenshot where the microscope is like the background, and what you're seeing here, the over table, set that as like a subset, so you can see kind of where I'm at in the room, plus you get the downward view. I'm working on it, guys. I'm working on it. Okay, so I have a, what is this? A 330 ohm. There it is. It says 330, but it looks like it's 330K. Let's fold this guy over. Need to order something to teach my kids. You know something? It's funny because soldering kits, kids, you remember back when we were kids, like you could get wood burning kits and stuff, and that was basically a soldering iron. It was the same thing. And we used to love doing like wood burning and stuff. And you know, now there's so many cool electronic kits for kids where they can build their own things and whatnot. I mean, there's so much cool stuff for kids. And my kids right now, other than my daughter who just came in a few minutes ago, she's very curious about, you know, what I'm doing and stuff, especially when she knows the camera's running. But maybe my daughter will get into this type of stuff. I had them help me build my CNC machine. In some of my videos from, I don't know, 5-6 months ago to a year ago, I had a giant CNC machine behind me, a large aluminum framed CNC router. And my kids helped me build that piece by piece. Like, I had them drilling and tapping aluminum and stuff to build that. And they loved it, you know. Other than every once in a while you getting a aluminum sliver in your body, which, I mean, is going to happen. Other than that, you know, they really dug in and appreciated that. KiwiCo. Yeah, KiwiCo is one of the kits that you can do. Snap Circuits is definitely... Snap Circuits got some interesting stuff. There's a whole bunch of electronic kits. Where is it? Where is that little bad boy? What did I do with them? So you can get electronics kits just like this off Amazon, and they're what, $50 for the best kits, and some of the other ones are cheaper. So these ones here, they come with a legend, and they come with LEDs. You got buttons, you've got capacitors, you've got chips. I mean, because you can do certain things like timers and whatnot. But even for their value in just parts, these little, what are these, Arduino kits? They're worth their weight in gold just in parts. Like the variety of push buttons that they give you and stuff. Those, I'm telling you, those can be so useful. I got light sensors, I got simple transistors, but this was like 20 bucks for this kit, and how cool is that? And it's got a little power supply unit right here, but all my little wires, here's one of the things I got them for. All the wires are pre-terminated for breadboard. So I think you just go to Amazon, you look up like breadboard kit. Here's the little breadboard. All the wires are terminated. It's got little risers and stuff. I mean, for like 20 bucks you can get these things, and they have all these parts, hundreds of parts in there. And even if you just keep these just for the rainy day when you are doing something and you need a part, you can open up your electronics parts kit and just surf through and find something that you need. But if you're doing work with Arduino, it's an incredible little setup. So that's, just look up breadboard kit or electronics Arduino kits, and you'll find so many of them. They're so cool, and you can do so much stuff with Arduino. Well, here's a perfect example. We've got one that's going to simulate ECG, and we got one that's going to read it, and that's all based off Arduino. Last component, guys. Last component. Here we go. Here we go. So this one here is a 22K resistor. And I'm going to pop that guy on there. Let's solder him up real quick. Flush cut it. And then this kit is done. There we are. Now this would be my first time soldering in this kind of microscope. So I can see what's going on here on the screen. I noticed that it's not bright enough, so I'm gonna have to bring in a spot. Actually, I have a spotlight. I've got a Welsh Allen light that it's got a big gooseneck, and that's gonna help out considerably. So I'm the old school type where I like working in a set of binos. So if I'm doing an examination on a board or something, I like having it right here in front of my face versus looking at a screen. It doesn't feel the same when you're looking on a screen. Like, I have a direct tactile connection to what I'm doing versus over here. I'm manipulating an object according to what I see on a screen, and it's not the same as the response you get when you're looking straight through a bino. So that's something I'm dealing with. But anyway, let's see. Here's this. And let me get a brush. Got all sorts of brushes. And what I'm going to do is I've got some electronics grade alcohol right here. And my favorite handy dandy little my waste container. And I've got this flux on the back of the board. So what I'm going to do is put a little bit of electronics grade alcohol. This is 99%. I got it at the H-E-B, which is a large grocery store here in Texas. It's funny because I've had to go, to electronic stores and stuff just to find 99% alcohol. But here they sell it right down the street. I love it. So all I'm doing is with a nylon bristle brush, I'm scrubbing to break up some of that flux that's on the back of the board. For one, it allows me to see the sockets a little bit better. There they are. There's two of me. So anyway, allows me to really get in there good and see how good the soldering job is. And I'll put it under the microscope here in just a moment so that you guys can see a better view. What do we got? Man, most of those look really good. I have one, maybe two pins. I'll show you exactly what I'm looking for. Here, got this little fan over here. So the cool thing about the 99% alcohol is when it evaporates, it leaves behind little to nothing. And that's good because the 70% will leave behind mineral residue from like mineral water, or it leaves behind moisture itself. So let's show you the two pins out of this whole thing that are in concern. And let's do that now. All right, so it's gonna be way easier to see this now that the flux is all gone. So I want you to take a look at two little pins. Here we go. I'll use this solder to point it out. And with the flux, we couldn't really see it, but check out this pin right here and this pin right next to it. See that? All the other ones are looking really good. But you got this one and this one right here. Those two need a little bit more love. They'll probably work just fine, but if I can see part of the socket sticking through. Here we go. Okay. Let's see, how does that look? They're looking pretty good now, huh? There we go. So all the other connections are looking really solid. No bridges. You can see when my iron pulls away, you see how I got some of the solder that's sticking to the tops. Come on, stop. And just clip those. Or I could touch them up with my iron again. I mean, it doesn't really matter. And a lot of that wouldn't happen if I was also using more flux. So let's see, let's take a look at some of these over here. Those look like pretty solid connections. Okay. So, the last piece of the puzzle, we have this guy right here. This is our nano. And what I'm going to do is I'm going to pull the nano off. Oop, careful, careful. And then it is going to get seated right here. Okay, nice and square. It does have a little indicator right down here that says USB. So you just make sure that that USB is in there. We press it in. And that's it. That is it. What a cool little kit, guys. That was a fun little project. So, screw down terminals. I've got RX, TX. So, I mean, there's still some expandability that we could do. All my switches. Everything's looking good. So next time I'll do a video where I assemble the ECG reader, and we will see how it works from there. Guys, I think that worked out quite well. Everything looks fantastic. All right, guys, so I'm going to end the stream right then and right there because apparently I have done everything. So, guys, that's our little ECG simulator. That's the simulator. And next time we're going to go ahead and we're going to assemble the ECG reader. All right. Anyway, guys, I hope you like this. Maybe next time I'll have a little bit better camera controls because the microscope right now, I don't know. Maybe I'll get a better microscope. I really like the focal distance on this one, and it's got a large grip, so I can adjust the zoom. Maybe if I can find one that's got I don't know, some auto zoom, or not zoom, but focus, autofocus. But it is what it is, guys. At least this one project came out nice, and you know, maybe tomorrow, the next day, I'll assemble the other one. This guy right here. So you can find these kits at htmworkshop.com. Very cool kits, and I know the guys that are running the show over there. It comes out of Florida, and they are doing some phenomenal stuff. HTM Workshop also on YouTube. Check out their YouTube channel. They make better videos than me. That is for darn sure. Maybe not as often as I post, but they still make some pretty good videos. And he gets right down and dirty on some of the theory. So check him out. Thanks for watching, guys. I appreciate you. And I will see you next time.